Good day and welcome to this our second lesson on using AutoCAD. Today we're going to be learning about doing building layouts and using basic drawing tools within AutoCAD. As this is part of the Stellenbosch University courses, the design, especially the concrete and steel design courses, and our final fourth year design course. Now, in our last lesson, it was basically familiarizing you with AutoCAD, the interface, what a drawing looks like, line types, all those sorts of things, model and paper space. Now, in today's lesson, we're going to go on to actually drawing using the various tools within AutoCAD. But rather than doing it the typical way AutoCAD lessons go, with you one by one learning each tool, we're rather going to draw a building. As we go, you'll learn the tools required to draw the building. And so you'll get a feel for why you need to know the different tools, how you use them, and how everything fits together. So first we're going to set out a building. So you'll get an outline of a building and how do you set out grid lines, sheeting line, brickwork sizes, those sorts of things. And then we'll use drawing lines and polylines, offsetting, rectangles, matching properties, blocks, dimensioning, and all sorts of general drawing skills to create the work we're going to be doing today. As discussed in the first lesson, this is the building we're going to be drawing. This is a warehouse, a little store. It was built in Johannesburg. This is the 3D model we're going through. The original drawings, especially the steelwork drawings, were produced in Tekla, and these are the drawings. We're going to start producing some of these in AutoCAD. You'll see here we've got sections and details, truss information, gutter details, general information on the side, all those sorts of things. And there was another drawing with staircase information, platforms, holding down bolts. But all right, we're going to start in AutoCAD. Here we go, switch across. Once again, we're in AutoCAD Lite 2013. And today we're going to focus on this section here. How do we do a section that looks like this? And also, how do we create a set of grid lines? You'll see in front of me, you've got all these grids, A, B, C, D, E, F, etc. And 1, 2, 3. Grids are very important on any construction site because that is what you set out the building to. When the job starts, a surveyor will come to site and he'll physically knock in pegs or make a mark on a wall or do something that you know where this grid line is. And then the contractor and everyone else will set out their works from these lines. So it's very important to get these lines correct. Because as you see, the grid line is normally to the center of each column. You need to know where those centers are. Rather than to the edge or the side or the middle, where you have this right in the middle of each line you normally put your columns, etc. Now, just imagine you got a big block like this from the client, saying, the building must be roughly 63.6 meters or roughly 15.7. He has a space like this on his site which he wants to fit this new building in. This actually came to us in a form that looked like this. Let me just swap to it now. A layout of what he wants. Not a lot of detail, not a lot of dimensions, but at least he wants to put racking here, and we know we need 6 meter clearance for his racking. He's got such and such space, and if you measure off this, you get an idea of how big the building must be. But now let's go back to our drawing and say, all right, now how are we going to produce that? How are we going to get to this information here from a basic outline? Firstly, we need to know what distance our grids are apart. Normally for steelwork, for truss spacing, so I'm going to go to my 3D model here. These sorts of trusses, there's a truss, there's another truss. The space between trusses can range depending on the type of structure, what you're doing, layouts, etc. For something like this, between probably 5.5 and 7.5 meters is fine. You could even push it up to 9 meters. As the bays get bigger, just the purlins, these sections on top, get heavier. So it depends. There's a balance between having bigger bays and more trusses. So you can play with that to see what the most optimal section or optimal structure is. But for now, we're going on about a 7 meter grid spacing from truss to truss. So if we go back here, you can have a look at 63 meters. You can just fit in a whole bunch of 7 meter grids. But just to double check that will work, what you need to know is where is your sheeting line, because as you can see, the center of your column is a bit back from the edge of the building. And if the client's given you a dimension to the edge of the building, you need to know what is the dimension between your sheeting and your building. Now, in some projects, you might just be given the sheeting, the grid lines directly. If there's an architect who's been involved already, often you'll just get given the grid lines, or sometimes the client has certain requirements, so he gives you grid lines. But let's say in this case, you've only been given a sheeting line, and the sheeting line is to the inside sheet. That is here. I'm going to go find a picture of that. In this building, the sheeting line would be the edge, the outside face of this girt, and the girt is sort of a cold form lip channel steel section which you can screw sheeting to. That would be your sheeting line there to the edge of that piece. The sheeting line would be to the inner face, the inner flute of this sheeting here. And your sheeting line in this picture would be from the center of that column to the outside face of that girt. And that's what we've got to work out now. If to know that in the beginning, such that you can set out your building and everything ties together. Now I'm going to go back. First, you need to know what size girt you've got. And in this case, we've got a cold formed lip channel, 175, 65, 22.5. At the beginning of the design, you often won't know what size this is because you've got to size it yourself. But normally you can get a feel from experience what size you'll need. Let's say I'm working on a 7-meter grid. I know a 175 millimeter deep section will be sufficient in a shape like that. You also need to know what column size you've got here. Based on the height of the building, the forces going through it, and how this fixes together, you can get a feel for what size column you need here. And I know it's going to be roughly a 305, 102 column, and from design you'll normally get to the exact size, the 29. You can go and draw out this section each time you want to use it, but normally the easiest thing is just to get a database off the internet, and to go to a database that you can get. Here we go. This is from the Steel Institute, the South African Institute of Steel Construction. They provide this free of charge online, thanks to whoever Lombard Consulting is. This is available from their website. And here you've got AutoCAD blocks that you can go get. And here I go. I want to use that little section there. It's a 305, 102. Some data call it a 28, some call it a 29. 305 means it's 305 mils deep, 102 mils wide, and it's 28 or 29 kilograms a running meter. So I'm just going to copy that, Control C, and I'm going to swap back to my drawing. If I press Control Tab, I can cycle through the drawing. So it's Control Tab, Control Tab, 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 until I get back to where I want. I'm just going to paste it here. For now, I'm going to use it just now. All right, but I need to know what is the dimension between here and here. Firstly, I need to know, as I was saying, this column. So I can get my little column here, rotate him, RO, enter, and put where you're going to center the rotation about, press enter. Let me run through that once again so you can see. I want to now, the reason I'm doing that is because I want to move. I'm going to move him down here, and I'll run through how to move just now again. I want to make sure that that is in the right place. I can either go draw a line and then draw another line next to it and gradually make sure that these are all the right distance apart. But what's often easier is you get a pre-drawn section and you just protrude construction lines from that. So as I said, I copied and pasted this in. Now it's wrongly orientated, so I'm going to quickly rotate it into place. So I'm going to select it. I click on it. Now I need to rotate. And up here in the toolbars, in the home toolbar, there's a tool that says rotate. So I click rotate. Now it asks me rotate, specify base point. The base point is the point it rotates about. So I click somewhere. I'm going to click there on its center. Now it says rotate, specify rotation angle or reference or copy. What I'm going to do for now is I want it to rotate 90 degrees. So type 90, enter, and it rotates. So, or I could do this using the command prompt. I type RO for rotate, press enter. It says specify base point. I can specify the base point wherever I want to. I can specify there, and then type 90 again, and it's rotated. Let me do that one more time. There, rotate, click 90 degrees. All right, I'm going to move him into place, and one thing you'll see as I'm drawing, little sort of rectangles, triangles, squares keep popping up. Those are snaps. Those help me draw to where I want to go. All right, let's move him down here so you can see. I think this original layout, you'll see there's a slight difference between the 28 and the 29. Slight difference between the two columns we've got here. It's probably because the original layout was done with the lighter column, and then with the detailed design, the size was changed. I'm going to move him out the way there. So now that I've got him there, imagine if none of this is drawn. Delete it. I want to now draw a column above. First of all, I shouldn't have deleted that grid line. I'm going to just delete the column and stuff around it. What I can now do is, I've got him here, and let's say I've got a foundation drawn. I'm going to go draw him just now so I can show you from scratch how to get to this brickwork here and this foundation there. I want to now project the line from this upwards so I can draw a column. So there's various ways. Either you can take a line, so you click line, you click the point you want to draw from, and you draw up to wherever it is to go. Or I can draw a construction line, and once in a few minutes I'll get back to the snaps that we're using again. I can draw a construction line. So if I use the drop down menu, go to construction line here, click construction lines is a line that just runs on for infinity in any direction, and this can go in any direction. Here we go, and I can draw him. I've got a line that now goes up, so either I can draw it using just a standard line, a construction line, or I can draw the first line. Now I can copy him across, so that I'm just going to copy him, so I can click copy. Now I need to specify a base point at the bottom, copy, specify base point or displacement mode. So I'm going to select a end point there and move him across and click and click. So I've created a couple more lines. Now I know that column is drawn exactly to the right size, that those widths are exactly as they should be. If it's half a mil out here or there, probably won't be a big deal on an engineering drawing, but just be careful, because the more accurate you can be, the better. Now, these lines you can see are not the right type. I want them, as you see, my yellow layer is steel, and as we discussed in the first lesson, different colors have different thicknesses. So I can now select these and select the layer and change them to steel. Click on steel, and they are now on the steel layer and have been turned yellow. Another way to change the layer, if I can go Control Z, undo, undo, I can match the properties. If, like we showed in the first lesson, if you go to match properties there, top right, click match properties, and I go to something which properties I like. Here's some steel up there, click on that, and I can change this now to the steelwork. Alright, so now we've drawn a column. But now the column, I can move him out of the way. Just get him out. The column extends too far. Let's say I want to trim him off at that level. Either you can go and manually adjust, so you click on the line and you click on the point, and you click on the point, and you can go and manually adjust all of those. Otherwise, there's a faster tool called trim. Undo those. It's up here. Within extend, you've got extend and trim. These are very useful when you're modifying the length of any item. I click on extend now, and I want to stop all these 4 lines on this line here, so I click. So once I've clicked on extend, let me do that again. Extend, select objects, or select all. So I'm going to select an object where I want to actually trim it. Sorry, I'm being foolish. Trim. I'm going to trim it to this line. Press enter now. That's the line I'm going to trim it to. And if I click on these, you'll see it trims it. Or I can select multiple lines at once and trim it. So it's a very quick way of trimming lines altogether. So let me run through that again. I'm going to click trim. The line I want to trim to, press enter, and then I can select multiple lines at once. Be careful. So let's say this is my grid line. I don't want to trim him. If I go over him, I will accidentally trim him. Alright. So let me do that last time. Trim. Otherwise, one thing you can do with trim is you don't even have to select a line you trim to. You just select trim, and then instead of now selecting a line, I just press enter, And now anything I trim, it will trim to the nearest line. So I can click it, and you'll see on any of these, it will just trim to the nearest line. Undo those. Alright, now that I've got my column, I want to know where is my girt. So I've got my girt drawn there, and here's a 175, 65, 20, 2.5, which means it's 175 mils deep, 65 millimeters wide, it's a 20 millimeter lip, and it's a 2.5 millimeter thick plate. And he is now out here, and one way to draw him is to use a polyline, because if you see I click on him, he comes up in as one unit, as in all those lines are almost grouped together. And a useful tool for that is called the polyline. So I click on a polyline, and this then draws a continuous line all linked together, because you'll see these lines we drew, they're all on their own. They're not linked to anything else. Whereas if I want to draw lines that are linked together, click polyline, select somewhere, I can go 20 mils. So now I click there, and I want to tell it how long. So I move my cursor in the direction I want to draw, type 20, enter, 65, enter, 175, enter, 65, enter, and 20, enter. And I have a girt. I have a hole-formed lipped channel girt, which we can screw sheeting to. And if I match the properties of what I want to match to it, it is now on the right layer and the right color. And this you can see is on the layer steel cold-formed lip channel. I quite like keeping different sections of the structure on different layers. So steel will be, my main steel will be one layer, my cold-formed lip channels will be another, my bracing might be another. It makes it easier, as you'll see with time, to isolate things. But now, where must he go? We have this cold-formed lip channel. Where must he stop? As I've drawn it right now, it's quite easy to see. Now, there could be two things that govern where this girt stops here. Either it will be the size of the girt and the size of the column, and then the brickwork will be adjusted to suit, or it is the size of the concrete column or concrete plinth, this concrete 460 by 460 plinth here, and the size of the brickwork. One of these will govern the space of where he falls, that little girt there. So what we need to know is also how big are these sections here. Now, looking at my layout, you probably need to do a rough sketch. Firstly, you just start sketching out a line diagram, and from the line diagram, you get a feel, okay, this building is this size, and you look at it and, okay, I know I need roughly a such and such size. And I've got a 460 mil by 460 mil plinth that I have found that I need. With detailed design, you'll have to confirm that. If in doubt, you can give yourself some tolerance. One useful thing is to size your concrete to match brickwork sizes, because brickwork comes in standard 230 millimeter widths. You'll see here, if I go to my plan view, this brickwork, this double hatch line, these two lines here, there's a hatch, they are 230 mils wide. This is a brick skin, and it's 230 mils. That is the sort of standard. You do get sort of 220 mils if it's not plastered or whatever, but generally people to work to about 230. In a single course, you'll see two courses of brickwork come up, or two skins of brickwork come up, and then one goes past this concrete, so it's 115 mils. That's a common practice. You have two skins of brick, and one goes past and one stops. Or if you want, you can put both past, or you can even put both past with a gap, or you can even have the brickwork stopping on the concrete, but then the concrete is visible from outside. So it depends architecturally what you want. But now in this situation, let's say now I know that I need my plinth to be such and such a size. Let me create a new layout so I don't do any more damage to this section. I'm going to copy this, so I'm going to click type copy, CO, copy, and move him up. So he's up there, escape. So I now want to draw that section. This is concrete here. That's concrete in the green, and with a brickwork skin on the other side. And I want to know exactly, well, to get all those dimensions so I can set up my building. Firstly, let me draw an arbitrary line in that will represent the floor. So that's my floor level. How tall must this concrete plinth be there? There are different ways to set it out. Sometimes the window will govern it, sometimes various site requirements, ventilation, all sorts of things govern it. In this case, it was just a little perimeter wall they wanted. So the dimension you see there is set out to suit the size of bricks, because that is 1220 millimeters. This is actually 13 courses of brickwork with a roller course on top. Now I'm going to go to a picture so you can see what that is. Standard course of brickwork, one brick with a bit of dugger in between, the sort of grout that sticks it all together. So one course of brick plus dugger is about 85 mils deep. So it's useful to work on 85 millimeter courses when you're setting things out, that everything is set out in increments of 35. However, on top you'll see you've got a roller course. A roller course is a brick turned on its side. He obviously then is half of a normal wall, so it's 115 millimeters. So it's 85 plus 100 mils on. That got here. We needed about 1.2 meter wall, so it's 85 times 13 plus 115 gives you the 1220 dimension. Alright, so I want to now put a line there so I can draw up to it. Either to create a line 1220 millimeters above this, I can just draw an arbitrary line. So click on my line tool, click somewhere here, go 1220 up, and then go across. Now I've got something to draw to. Or what I can do is offset this line. Just select those and press delete. Or I can offset this line here. So I click offset, and then I type in a dimension 1220, press enter, click on this line, and I offset it. An offset is a useful tool. It creates the same line as you offset a specific distance away. If you offset a polyline, let me show you here, it will offset all of it. There you go. So you can see it functions slightly differently if it's a line or polyline. Right, so I'm going to go back there, delete that. I'm going to offset this. So I click on offset, and then you'll see offset, specify offset distance all through, erase layer, etc. So I'm going to type 1220, enter. Alright. Now I want to add on the size of the plinth. I know that from experience that this is going to be roughly 460 by 460. So coming back, this is 4 skins of brickwork, so it's 4 times 115 millimeters will give me my 460 by 460 plinth. So I'm going to offset this to create my 460. So I click on offset, and it will be 230 mils either way. So I type in 230, enter, offset it that way, offset it that way. Alright, now where does my foundation start? This foundation dimension will depend on your site, depend on your requirements. Either you have to dig down deep enough that you have suitable bearing pressure there so that the soil is strong enough. Sometimes there are surfaces going here that it needs to be deep enough that surfaces can go over it. Sometimes there will be pits here or downpipes or various things that have to go on top or below. So all those things will impact how deep your foundations are. So be very careful looking at all the different factors when setting out your foundations and what level it is. Let's say on this site I need to be 650 millimeters down such that I'm on competent soil. I'm going to now offset that line, offset 650 mils down. Now what I've created is an outline of that concrete plinth I want to draw. So now I can click on this rectangle tool, I can go rectangle, and I can draw in a rectangle which will be my plinth. So I could otherwise create that using a polyline, and just click on all 4 corners. There we go. And now I want to match the properties of that, and either I click on it and I select it and make it concrete, or I can go back and now do it manually by matching properties from something nearby. Alright, so now I've got that. I've got my 460 millimeter piece of concrete here. I now need to put some brickwork in front of him. So I'm just going to do a polyline, 115 mils wide, polyline 115 out, all the way down. And when you see that little symbol, that perpendicular symbol, stop and across. Then I'm going to make this brickwork. So I click on it and make it brickwork. go, BWK, brickwork. Now I am drawing this. From this, I can start getting a feel now. Where should my sheeting line be? Because that's where what we set out at the beginning of it. Because there's my girt. You can see that if I have, I'm going to copy this to the top there, then we put this new column. So I'll type copy, CO, enter, and actually let me select him as well. Select all of it together, type copy, enter, select the base point. There we go, the intersection, move that up here. If I put this girt right against the column, you'll see that when my sheeting comes down, it will clash with the brickwork. It will foul this skin of brickwork here. That's that box there. You can see it. That's the brickwork there. So I need this girt to be a bit further back from the column. So, and normally you want a little bit of the space between the sheeting and where the brickwork starts, because the tolerance is never perfect. You can see in the situation, I mean, brickwork is not 100% accurate. It's give or take a brick sometimes, but in this sort of situation, normally it's about 10 or 20 mils. So I want to give myself some tolerance between where this girt ends and where this brickwork starts. So in this case, I'm, let's say, about 30 mils. So I can draw a line up. And if I move the girt, type M, move it, so incorrectly selected, I think. M, enter, and move it out to there. Or another way to move it is I click on it and I type move. There's move up there. I click on the point which I want to start moving from. I move in the direction. I type 30 millimeters. Enter. And there we go. That's where the girt should be now, because either the brickwork line or the sheeting line is going to determine it. As you can see, the brickwork line was further out than my girt. Therefore, it governs it. So I could set out my brickwork 30 mils back, and there we go. There we start our line. Right, this might seem a bit sort of strange. Now, why do I start with all these sorts of strange things, sheeting lines, etc.? Because once I've got this dimension, once I know what's the distance from here to here, I can start getting my overall grid lines. I've got this dimension worked out, is now annotated, so you can see there's a dimension. It's 375 millimeters. I think on this, I think I just used a 30 mil gap there, where normally I picked a 25. There we go, that's a 25 mil gap. Once I have this sheeting line here, this 370 mil sheeting line, I know what the space is between my grid lines and between my beginning of my sheeting all the way around. And from that, then, I can set out my grids. Because let's say this is 6,300, that dimension there. And if I subtract off the sheeting line each side, so from the inside of the sheeting to that line, I'll get a total dimension like that. And then I can just double check and say, well, if I divide this by 7, do I get to an answer I can use, or 6.5? So often you'll find out, I've given you an example that works out perfectly, but you might have this as 6,900 or 6,750 or 5,825 or something. But normally you want it rounder. The rounder, the more easy to set out on site. So, but in this case now I've got 6,300, which goes beautifully into 7 meters. So I've got all these 7 meter bays here. And in this dimension, I've got 15,700. So I subtract these two sheeting lines and I get roughly 15 meters. So it works out nicely. I can set out a 15 meter grid and now divide the 15 into 2. So it's 7.5, 7.5, 7, 7, 7, 7, 7. So now I know what is my grid lines all the way around. As I said, if you start out with a situation where you know where your grids are, then you just get your grids and you work outward from the grid line to get your sheeting line in the same way. Okay, now that we've got our sheeting line, let's set up our grids. We know this distance. Let's start drawing out a grid pattern. So what we're going to do is draw a line somewhere up here. Let's start up here and draw that line down. We need to draw it roughly the length it needs to be. I'll match the properties in match properties of a line, a grid line, and I can select it. If you don't have something to match it to, what I do is I'd select this, and I go to home, and I go to grid, and maybe I have to set up my own grids layer. If I select it, sometimes you'll see that this doesn't look like this. It doesn't have the dashed lines that the rest of my grids do. This is because the line type scale is different. So I right click and I click properties. This comes up with all the properties again. And from here I can set out what the line type scale is, because you can see the line type is what type of dashed or dots or continuous lines it is. And you can play with this line type scale in the properties. So let me do that again. I select this, I right click, I click properties, and when I select properties, this window comes up, which gives me access to all the different properties. And I can type in, say, 50. Is that enough? No, that's not enough. So let's do 250. Alright, yeah, that looks more or less right. You can play with it though to get it to a scale that looks right. Actually, it's a bit more 500. There we go. Now you can see, that's a grid line. You normally have a grid line with a dash and then a small dash or a dot in between. Now, once I've got one line, I want to be able to create multiple grid lines in 7-meter increments all the way along here. I'm going to start with grid line A though, just so for convenience sake. And let's say now I don't have this layout here, I can't see it, so I want to put a circle on top with my grid in. It's grid A. So I click circle, the circle tool up here, and it's also got other tools. If you click with various places, you can do it. So I'm going to click center and radius, that one there. So I click at the center, I want to put my center there, and now I make it, let's say, a meter diameter, so it's a 500 millimeter radius, and it draws it out. Alright, let's match the properties to be like shown below. Now, either I can move this, click on it, and move it up so that it sits above that, or I could have trimmed the line. So I click on trim, press enter, and I can trim it. Now let's put some text in there so we can start annotating it. Here's multi-line text, and you click in the middle, and this pops up a window, and it'll also open this text editor here. So it's grid line A, type shift A, and then you need to set the size of this. The size will really depend on what scale you're drawing to. And so that's why in the first lesson I said, make sure you know what size roughly it is. But often you'll only know what size it is once you've done your grid line and you've checked what can fit on a page. But I'm just going to make this 500 for now. So there we go. That's 500. It looks about right. I'm just going to match properties to be like the other ones. So there we go. And let me drag that to be in the middle. So I'm going to move it, M, enter, and then put that there. Alright, now I'm going to create the grids, and then once we've created these grid lines, we're going to go through how to learn these tools at the bottom. So I select this, and there's various ways to now create this grid pattern. Either I can select it all together and go copy, CO copy, or use the copy icon up the top there. So copy, again, select it, type copy, enter, space, and then I can pull these sideways. You need to make sure your orthogonal function is on, i.e. everything goes at exactly 90 degrees. So click here, there's your ortho mode, or press F8, so I'm going to click on ortho mode. Alright, so now it's moving at 90 degrees. I can type 7,000, enter, alright, 14,000, next one, enter, etc. Or what you can do is you can draw a line, 7,000 millimeters long, line, enter, 7,000 millimeters long, and you can offset, you can actually use this line, sorry, let me move that back there, to copy from one to next. So, if I want to copy him, I select that one, I go copy, enter, I can use this base point now to copy from one to a next. Copy, 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 all the way through. However, if there's a standard spacing you use, one very easy tool to use is an array. An array creates multiple lines of an item and even multiple rows of it. So if I select this item, then I click on an array, this gives me various options: associative, base point, count, spacing, columns, rows, levels. Alright, we know how many grids we want. We've had a look at here and see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 grids, 10 lines, and that's 7 meter spacing. So I can say count. I want to count how many. So C-O-U, count. Now, select the number of columns. So we've got 10 columns. Select enter the number of rows. We've got 1 row. We only want 1 row. Now, so it'll now create 10 columns in 1 row. And now I need to define spacing. So S, enter, and here we go. Array. Specify the distance between columns. Now be careful. Since we are on this side, it is negative to the left and positive to the right, positive up and negative down. So we need to specify a negative 7,000 millimeter offset. Enter. And there we go. We've created a grid all the way through. So that, let me go through that again. Select my grid lines, select array, type count, C-O-U, enter the number of columns, 10, number of rows, 1, then spacing S, enter, minus 7,000, enter, and we are done. There we go, and press escape, that I'm happy. This now has created all the grid lines. One thing though you'll see when you've created an array like this, they're all linked together, they're all very much grouped. So what I want to do is be able to edit the text now in these different circles. So as it stands right now, it's difficult to do that. So I need to explode it, because this is all one unit. It sees it as one at the moment. And one thing with arrays, you can see it brings up these tools. So at the top here, you could go back and edit this and start playing with it. But I'm going to do it a simple way. I'm just going to explode this. So I'm going to go back to home and click on this button here, explode. So if I click that, there we go. It's exploded now. They're all in single pieces. So I can go through, double click, and start numbering all my grids, A, B, C, D. When numbering your grids, make sure that whatever grid system you use doesn't conflict with other things on site. If there were multiple buildings on the site, it's not a good idea to have them all go A, B, C, D, E, F, G, etc. What you might want to do is have a different system for building one is AA, and then BA, CA, or whatever, or other systems. There's various systems you can use, but just make sure there aren't two gridline G1s, for instance, because you might issue something or tell the contractor to do something at gridline G1, and it could be done on the wrong building, especially on bigger projects, or when there are multiple little buildings next to each other. I sometimes don't prefer using I leave the I grid line up because I can sometimes look like a 1. You'll see it was done here, but where possible, I actually leave it out. So I'd rather go HJ. I'd rather have people think that I don't know the alphabet than putting things in the wrong place. Okay, there you go. A, B, C, D, F, G, H, J, K. Now let's create some grid lines in the other direction. So I type L, enter a line, and draw a line across here. I can move that a little bit down, so I've got space for dimensions. I'm going to match properties, match, click, click. So once again, going to create offset it, and this is a 7.5 meter grid, which we worked out earlier, how we get to that 7.5, 7.5, and create that. Alright, now you can see I've probably made this line a little short. I'll need some more space. I'm just going to select all of it, move it up, get it away from other drawings. If I want to extend all those, because those are too short, the easiest way to do that is to select Draw, Construction Line, click here, project this line, press Escape. Now I use this to extend all my lines. So I click on this, Extend, Enter, and select all the lines I want to extend. And they will now all extend. There we go. So now I've got a bit more space there. Let me put now the grid lines. Which way was this numbered? 1, 2, 3. Alright, there. Then we can move that out. So we'll go select, move, space, space. 1, copy, enter, 2, and 3. There we go. So now we've got a grid line system. We've got something we can actually set the building out to. The reason I used two bays in this, because each of these, the space between a grid line is a bay normally. So the reason I did that is because on this gable face, the gable face is this sort of face here and here, the gable face, I wanted one column in the middle. So that was where the 7.5 came from. That I could have gone with a 5-meter bay. It was actually just easier because then this span is the same as this span, so it just made the girts the same all the way around, so it just was simpler, and also less bracing and less other things here. So that's why that 7.5 dimension came in. Okay, going back now. Now that we've done all of that, we can set out a grid. You've seen as I've been going, there's been a lot of things happening with these little tools that where if I try to draw a line, for instance, it snaps. You'll see that there's a cross that pops up there, or a triangle, all these various things. These are the snap tools. They're down the bottom here. Snaps are extremely useful because then you know it will sort of zoom your pointer or track your pointer to the nearest of certain types of points. And if I want to adjust the snaps, the object snapped, you turn it on and off with F3. It's quite useful while you're drawing. You can turn it off just pressing F3. But here we go. I'm going to click Display, Settings. Right, so you right click on your tools and you click then Properties. This is the object snap tool. This will just determine what it attracts your mouse to. You can select endpoints, midpoints, nodes, intersections, all sorts of things. Nearest is sometimes quite useful because it pulls you onto a line, apparent intersection. So all these tools you can use. So, and then that shape next to each one, that will pop up depending on what you're on. So you see midpoint is a triangle and endpoint is a square, etc. So, and an intersections an X. So if now I get out of that and I try to draw a line, you'll see that I've turned off my snaps. If I turn them back on by clicking there, it'll snap to, there we go, there's the square popping up for the endpoint, triangle for mid, X for intersection. You can activate the snaps while a command is active, so I can start drawing the line and then activate and then turn it off. But so your snaps are very useful. Learn to use these so you can draw to the right places. Other tools down here, you've got snap and grids. You can turn on and off grids. So when you turn this on, if you adjust it, it'll actually hold your cursor to there. Settings, meter apart, and a meter apart. I honestly don't often use grids. They're often more of a problem than not. If you turn it on, I'm not doing it right now. It basically tracks your pointer to a grid setting out, and it becomes a bit of a problem because sometimes you just want to be able to draw in mid space and it just doesn't track it to the right position. You can set up a grid. You can turn grids on and off if you want and set it up so that grids are displayed in the background. Ortho mode is very useful. This third button along. If you click on ortho mode, it turns off such that if I start drawing a line here, you'll see that either I can draw it in any direction, or if I turn ortho on, it forces it to go in only 90 degrees up, down, left, right. So, and as you see, I've got this command active. It's making sure my line only goes in certain directions, but I can turn it off once I've drawn a couple of lines, I can turn it off and then draw in any direction I want to. One thing though, even if ortho is active, you can click on a point and it'll still bring it to that point. And you just select all of this, delete it, and delete it. Now that's ortho. You can also have polar tracking. Polar tracking is like ortho, except that it tracks it to degrees. So let's say if we turn 22.5 degrees on, you'll see it keeps it even in increments of 22.5 mils when you're drawing. So that can be quite useful depending on what you're drawing, especially orthogonal type views or whatever. And then, so yeah, polar tracking. Normally I just use ortho, turn that on and off. Object snap. And then there's various object track snapping, dynamic input. Dynamic input means while you are working, it allows input right in the pane of window. You'll see while I'm drawing this, it allows input into where my cursor is in the middle of the screen. I normally don't draw with dynamic input. Also, there was a bug with my version of AutoCAD and dynamic input a while ago. You'll see it still when I was using it slowed down quite a bit. Show hide, and there's various other quick properties. You can click on something and you get properties, selection cycling, and annotation monitor. So there are various tools down the bottom. The most ones you'll commonly use is object snap and ortho and those. So now that we've got a grid, we know how to use these tools, and I showed you how to use the sort of ortho, polar, etc. Once you can see how you actually draw the line. Let's continue now with creating our layout. We've drawn our brickwork. We've drawn our girts. Now we want to continue drawing the rest of this building. Delete that out the way. Let's now create the rest of the grid lines. One way you can do this is if you create your grid lines first and then you come down to create your section, you can actually project lines from this. So I select all of it or some of it, and I can copy and paste it. So click copy there. And if I want to paste it, but I want to paste it as a unit, I go insert, create block. And then you can do this in various ways. The easiest way is otherwise you select it, create block. Alright, and now I can define a name grid, set out. We'll see what a block is in a minute. Okay. Oh, I didn't do that right. Sorry. Let's insert create block. Grid set out. Grid set out. Okay. Now select objects. It selected it. Okay. Okay. Oops, I'm doing this all wrong. It's always when you're trying to explain it that you end up doing it a million times. The easiest way otherwise to create a block, you select all of this, you create Control C, Control copy, and Control Shift V, and it pastes it there. What I've just done is create a block. There you go. This block now, this sees it as one unit. And the reason that is useful that I can just click and drag this around quite easily to create the rest of my drawing. So I rotate, RO, enter, turn it 90 degrees. I now have some grids I can use with, so I can move those. And especially if you've got a complicated drawing pattern or complicated grid, I can just move this around and project grids from one to another. Alright, so I've got that now. I've got to put that across, create some other grid lines, copy, move across, move across, move across. Okay, and I can label these all. What I could have done is drag those down. 1, 2, 3, 1, 2, 3. If I want to trim it, do the same trick with going to line, across, there we go. Actually, I didn't need to do that. The lines I was looking at to trim came from above. Alright, now I've got a grid line pattern. I've got my sheeting line, I've got my grids, I've got everything. Now I can start drawing the rest of the building. Actually, before I do that, let me just draw on the floor so there's no confusion and complete these bases and plinths at the side. So I'm going to match the properties from that section there to my floor. That will be the top of the floor. I'm going to trim that. So trim, select where I'm going to trim it to, press enter, trim, trim, there we go. And now I'm going to put in a foundation. The foundation, you need to know roughly how big your foundations are. In this case, these foundations here, that's a foundation type A. It is a 2000 by 1200 by 250, 21 by 1200 by 250 base type A. I'm going to draw that in now. So I want to put that there. I'm going to take a rectangle, draw a dimension, enter, 210 by 250, and I've got a square. So to go do that again, click on rectangle, click where you want to start drawing it, type D for dimension, enter, 2100, enter, 250D, enter, and press enter when it's on the right side. There we go. And I can move this in place. Properties in A, and then make it on the concrete layer. Alright, so now I've got a foundation there, ready to go. I want to mirror that across the side. So normally what you do to reduce the amount of drawing is you draw one thing and then you use it as many times as possible. So I draw that there and select all of it. Now I want to mirror. Because this grid line's right in the middle, I can just mirror about it. So I select everything. Now I use my mirror tool. Mirror, click there. Select now it says mirror, specify the first point of mirror line. So you click and you create a line. And I click again there. Press enter. There we go. That's creating an exact mirror image of that side of the building to this side. Let me delete that. Select all of it. Mirror, enter, mirror. There we go. Right, so now I've got the sides of the building. I know what more or less the sides of the building. But where does my truss come? Where does all of this stuff fit together? But if you remember the drawing we had a look at earlier, they said they need 6 meter high racking. So we're going to take it that the top of the racking is exactly 6 meters to the bottom. So let me put a line. I'm going to make that a line 6 meters above. So offset that. 6 meters, 6,000 up. There we go. Now that is a line. I'm just going to move it a little bit to the right. That is the underside of my truss. I now have a position from which I can start creating my truss and my roof structure. And if I have a look at it, I can have a look at the span. Normally you'd have to draw it once or twice to get a feeling for how deep the truss is. In this situation, I know it's going to be about 1 meter. So I'm using it as a portal. I'm connecting it to the frame to carry the forces. But you could probably make it a bit thinner in this case. I'll just move those up to give space. So it's 1 meter. And also the architect wants the roof slope to be at 3 degrees. So I've got 6 meters up, a line going at 3 degrees off. So let's start creating that. And then I'm going to have a 1 meter deep truss on top. So what I can do is select this line and rotate it. Click on rotate. Point there. And I'm going to select -3 because of the direction has to go -3. Alright, that is now at 3 degrees. But I'm going to make that a steel line. So this is steel. There we go. And now let me make this meter deep. So I'm going to offset my truss. There we go. Offset function. Type in 1 meter, 1,000. Alright, now we've got the depth of our truss. Now we've got something we can start working with. But let me start drawing the columns up. So we're going to select column, extend. Select that line, press enter, and extend up these lines here. So we've got something to draw to. We'll tidy up this bit at the top maybe later, but now we've got something to fit those, the truss in between on. But the next question is, how far apart must all these diagonals and vertical members be? You can see they're all drawn in there. What sort of distance? You'll see they're 1800 now. A good way to set that dimension is to know what type of sheeting you've got. So I'm going to go to our catalog here. I've got an IBR sheeting. This is an IBR 686 profile from GRS, from Brownbuilt. You can go on their website and get the sheeting. So I've got an IBR, it's a 686. The IBR looks like that. That's the profile. It's a very common sheeting. It's sort of screwed onto the steelwork. We also get concealed fix where it's not screwed on. The concealed fixes are good in terms you probably get less leaks because you don't have less penetrations to the sheeting. But this sheeting is secured more firmly. There's various cost issues either way. Alright, but these are the allowable spans that a 0.58 millimeter thick galvanized IBR 686 sheeting profile can take. That's the 686 profile, that's the 890. If it's a roof span, the furthest it can cantilever, it can stick out sides 450 mils, an internal span of 2.1 meters, an end span, i.e. if it's the last bay 1800 and the single span 1750, and on the walls it can span further. So normally from your sheeting, you can decide what spans should you use. I normally leave my sheeting spacing between 1800 and 2 meters. 1800 is normally between those two. you can normally look at using. So we're going to start now setting out this truss so that our purlins, those sections there, are set out roughly 1800 mils apart. If I go to our 3D model, you'll see those purlins sit on nodes. They're always on top of the truss structure. That's because the load then doesn't create any bending in this top chord of the truss. So you always put your purlins directly on top of your truss there and the truss nodes. There are ways you can put it not on a node, but then you just need to make sure that this member is designed to carry that. So we're now going to start setting out where all these purlins are all the way down, so we can screw our sheeting to that. So what I'm going to do is draw a line enter, and perpendicular, match the properties of it. Now I'm going to offset this 1800 millimeters. Offset 1800 mils, and get a layout all the way down. Sometimes what you'll do is, otherwise, just take your overall dimension, divide it up, and you can roughly get a feel if that is correct. The way I've done it here now, you'll see you've got all your 1800 mil spans and then little bays at the ends, just slightly shorter. It's worked out quite nicely. You might have to play with the numbers to get this working out. One of the ways I do it is you don't have to do this, is you make your end bay a bit shorter. Normally all the work that happens, so the guys walk up and down while they're doing gutters and side sheeting stuff. So this area gets abused at the side more than anywhere else. So sometimes you make this last span a bit shorter, and also your wind loads are normally higher at the side. However, that's purely preference. Some people do it, some people don't. Some people have every bay the same. Your steel contractors probably would enjoy every bay the same. But one consideration also is that normally your highest forces occur in this last member, that member there, especially if it's continuous into your truss. If it's pinned support, then it's not. But if it can be often very high forces in this member here. So if you have it shorter, it's sometimes a higher resistance. So that's something to be aware of when you play with layouts. So now I've set this out so that the last bays are a bit smaller as discussed. And then I can start linking it up. So I can just do that. Let me change this layout because I'm drawing lots of steel work. Change this to steel and start drawing. Normally you'd want to get this to a nice dimension. I'm just going to draw it roughly. You can play with this yourself to get all these dimensions working out nicely. These ones are perfect. And then somewhere along the middle you actually change the direction of it. Let's do that. Right. So I've got all my diagonals now in that. There we go. I've got a truss. The truss is drawn, and I can trim those lines now to the face. Before I do that, let me just get some purlins on top. Once again, 175 cold formed purlins. If I wanted to draw those from scratch, what I'd do, polyline once again, polyline, PL, or let me do it from the line, polyline, start drawing, 20 mils up, 75 mils across, and 75 mils deep, 75, 20. Right, select it, change it to cold form channel, and there we go. I've got now my cold form channels to put on top. But the next thing is what dimension to make between this, and also which way should we orientate these cold form lip channels. You'll see on these drawings all your cold form lip channels always toe upwards, i.e. the open side it opens higher. Normally you'd think that's counterintuitive because you'd want to put it the other way around so stuff, sort of dirt and water doesn't collect there. But structurally it's actually better to have it shown like this, because your shear center, the shear center of the section is somewhere outside of the section here. So it's structurally better because the load goes closer to the shear center, so you have less twisting on your member. So that's the general reason why on roofs you toe them upwards. But once in a while people do break those rules. You'll see I've done it here, but that was simply so I could get a fixing because it was very difficult to bolt it in from the other side there. And there. Alright, so now I'm going to rotate this. Rotate. I'll use it from the command line so you can see. Select my section, rotate, specify the base point in -3 degrees. I need a bit of tolerance between the bottom of the skirt and the top of this, just for working, for space, for erecting, etc. So you can see there's normally 10 or 20 mils. It also allows some space depending on where the detailer, the guy who works for the steel company, does the final layouts of the steel work. This steel piece might shift up or down slightly, so you normally want to give yourself a bit of tolerance, 10 or 20 mils. I'll give it 20 mils, let's say now, 30 mils. Give it 30, move, enter, click here. If I turn off author, I can just move it straight up like line, 30 mils. Alright, now I've got my call for the channel. And I can copy this all the way down the roof to create a roof layout. Great. Up here. Here. This last one you have to be a bit careful of. You need to see how you will fix it to it, because you need to keep this cantilever distance down. If your sheeting is only allowed to cantilever certain distances, you need to maybe move it up, because you could put that cold form there, just to the left of the column, and it might be easier there, but this sometimes becomes too long. So either you can bolt it to the top of the column or put a section there to fix it too. There are various ways of doing that. You'll see on the 3D model, when they did it, they just had a cleat on the top, and that little T section bolted to the top and it connected to the last cold form. All of these channels, all these cold form channels, these girts, are connected by little T cleats to the trusses and to the rafters. Alright, so then we've gone through the main processes now of setting out the truss. How do we get the sheeting lines? Now it comes to setting out the girts. How do we get the spacing here down the side? Once again, you can check your catalog, and depending on the site, the height of the building, you can adjust these to be equally set out. If you have translucent sheeting, be careful. Let me go back to these pictures. That is translucent sheeting there. Translucent cannot span the same distance that steel sheeting can. It can normally only span about half the distance that normal steel sheeting can. So make sure your translucent spacings of girts is smaller. So see here, the architect wanted light, natural light, so we have translucent. So these ones are about 1 meter apart as to 1.5 to 2.5 meters down the side here. So that's why those. But then you come up the side and set out all of those. So right, so there you go. You can see we've gone through most of the details of creating the layout. And we can continue then with this to set out some dimensions here. We're not going to complete all the sides. I think it's fairly self-explanatory how you might do that. Just going to add that good there. If I want to start now dimensioning this, I can annotate it. There's various different ways. You've got all these different tools. As we said, you need to make sure that this scale is correct, and then the next lesson we'll have a look at it. For now, we know it's 1 in 50, so I'll make sure my dimension style here is on 1 in 50, 1 in 0050. Alright, and those we'll learn in the future lessons how to adjust those. I can either start dimensioning now from, let's say, there to there. And I've got 6 meters, or match with a straight dimension, a linear dimension. If I want an aligned dimension like that at an angle, I use the different tool, and I can start now dimensioning out this truss. Normally what you want to do is have dimensions aligned all the way down your truss so they can see what the spacing is between girts. If you want to now dimension to all of these, so you have a situation where it goes all the way down to each and every girt, you can use a very useful tool here called continue. So once you've done the first dimension, you click continue, and you can actually start setting out all the rest of them all the way down. You don't have to select the dimension tool each time. You can just continue it all the way down to there. And as I said, you probably adjust those end-day dimensions to get it, so you can dimension it. Just copy, enter, add some text to this, and start annotating this. Add some details, start adding some levels. It's very important to add levels to it so you know where to set it out from. So that is how to use the basics, and that was quite a lot learned in that lesson. We'll continue with these layouts in the next lessons, and then also start learning, now that we've got this general layout, how do we put it on a drawing, what sort of details do we need to show, etc., because we've gone, at least now we've got a building, purlins, girts, setouts, etc. In the next one, we'll have a look at a bit of bracing, roof layouts, all sorts of sheeting details, and all the various lights as we go through. Okay, but I'd say go back through and replay, try put this tutorial up and play, and try and recreate this sort of idea. You can use the template supplied for the course, for the dimension styles and such, or you can set up your own template, and you can start getting a feel for how you use all these tools. Alright, chat to you soon.